The automated alarm on the bridge sounded a single, sharp tone as the hull suddenly slid sideways, indicating the ship was moving directly toward the narrow channel markers. The vessel was the MV Pacific Swan, a standard container ship of moderate size currently navigating the final approach to the port of Charleston. It was late afternoon. The water was relatively calm, flat with only a slight chop, but the air held a heavy, muggy quality. Visibility was excellent under a high, pale sun. Captain Jensen, a man nearing retirement, stood on the bridge wing, overseeing the operation. Second Mate Rodriguez was handling the controls, assisted by able Seaman Chen on the radar and navigation instruments. The approach was scheduled. The Pacific Swan drew significant draft, requiring the use of the deep water channel. Speed was already reduced to 6 knots, appropriate for the area. The ship was fully loaded, making its response time slow to any change in current or rudder input. The main engine room crew, led by Chief Engineer Davies, maintained readiness, monitoring the propulsion systems and standing by for maneuvering orders. Everything was standard procedure. The entrance to the harbor was marked by a series of red and green buoys and lit markers, signaling the safe water boundary. The vessel needed to make a gentle turn to port soon, aligning with the dredged channel. The safe water area was narrow here, and the channel bottom dropped away quickly outside the marked boundaries. The risk remained that any unexpected lateral movement could ground the vessel. The initial movement was subtle. Able Seaman Chen was the first to notice the unexpected drift on the electronic chart display and information system. He spoke immediately, his voice flat and trained. "Captain, we are drifting 1.5 degrees to starboard," uncommanded. What happened? A powerful, unforecasted cross-current, likely a tidal eddy funneling between 2 small islands, had begun to push the vessel's port side. What the crew did: Captain Jensen immediately stepped back inside the bridge. Increase starboard rudder 10 degrees, counter the drift. What changed? The second mate engaged the rudder, and the rudder angle indicator confirmed the movement. The ship's bow responded slowly, but the cross-track error continued to increase. The ship was still being pushed right, toward the shoal area marked by the line of green buoys. What risk remains? The vessel was now pointed toward the shallow water outside the safety zone. The second mate reported the situation. "Sir, 10 degrees starboard is holding the heading, but the lateral drift continues. We are still closing on the channel limit." Captain Jensen watched the distance to the nearest green channel marker shrink on the display. It was too fast. The rudder alone was not enough to overcome the force of the current against the high side of the fully loaded vessel. The ship's inertia was working against them. What happened? The initial rudder correction failed to stop the lateral drift, and the current was intensifying its push. What the crew did: Jensen pointed at the engine order telegraph. "Engine room. Ahead full on the starboard engine. Port engine stand by to go astern full." The captain decided to use asymmetrical thrust to push the stern back to port, but only as a controlled emergency measure. What changed? The ship's starboard propeller increased its rotation, creating a strong forward thrust on the starboard side. This momentarily helped to turn the bow back to port, countering the drift. The ship's speed increased slightly. What risk remains? Increasing speed in a restricted channel increased the overall risk of collision or grounding if the correction was too late. The port engine remained on standby for a much more radical maneuver. The chief mate, who had come up to the bridge, grabbed a pair of binoculars and looked toward the green buoys. "Marker 5 is less than a cable away, Captain. We are running out of safe water." Jensen spoke into the radio telephone handset for the engine room. "Chief, be ready for rapid reversal. We need instant power." Chief Engineer Davies' voice was calm over the speakers. "Understood, Captain. Ready here." The drift became a slide. The bow swung slightly to port from the asymmetrical thrust, but the current was now overpowering the ship's speed and the corrective turn. The angle of the ship relative to the channel centerline was growing too steep. The risk of the hull hitting the soft bottom outside the deep water channel was immediate. What happened? The cross current made the ship drift too fast, and the bow correction was not enough to prevent running out of safe water. What the crew did: Jensen shouted the command to the second mate. "Port engine astern full, immediate." This was the most aggressive maneuver possible short of dropping anchor, a move that carried its own massive risks at this speed. What changed? The propeller on the port side began to spin in reverse. This created massive drag on the port quarter, which should pivot the stern quickly to starboard and stop the forward movement toward the channel marker. A severe vibration ran through the hull as the immense engine fought the current and the vessel's forward momentum. What risk remains? The sudden full reversal of the port engine put maximum mechanical stress on the machinery and created unpredictable rudder forces. The ship was now swinging aggressively, and the combination of the two engines pushing in opposite directions could lead to an uncontrolled yaw or potential mechanical failure. The distance to the marker was still closing, the problem was rising, and a more critical movement was required to avoid the shallow. The Pacific Swan shuddered violently as the port engine went astern full against the forward rotation of the starboard engine. The immediate effect was a rapid yaw to starboard, exactly what Captain Jensen intended to pivot the stern. Away from the danger zone, however, the unexpected current strength worked against this. What happened? The powerful current caught the already reversing port quarter and increased the stern's pivot rate beyond control. What the crew did, Jensen immediately countermanded the order. Starboard engine, stop! Port engine, reduced to astern half. The crew reacted instantly, pulling the engine telegraph levers back. The second mate called the orders to the engine room clearly. What changed? The violent yaw decreased, but the ship now lacked any effective forward speed to maintain steering control. It was virtually sitting sideways in the water, perpendicular to the current, which pushed the entire side of the hull relentlessly toward the boundary. The turn had been too aggressive, and the ship was now stalled. What risk remains? The vessel was broadside to the current, offering the largest possible surface area for the current to push. The drift rate toward the green marker in the shallow area was faster than before, reducing the remaining safe time to mere seconds. The initial aggressive reversal had failed to stabilize the ship. Instead, it had made the situation much worse. The bridge was silent except for the quick functional reports and the vibration of the still-working port engine. The ship was sliding rapidly. Able Seaman Chen reported the distance. 40 meters to the marker, Captain. 3 knots lateral speed. What happened? The ship was now rapidly approaching the channel marker, which signified the exact edge of the deep water, and a grounding was imminent. What the crew did, Jensen knew. They needed maximum thrust to break the current's hold and regain steerage, but they had to be careful not to create another uncontrolled swing. He made a difficult decision, choosing rapid, controlled forward momentum over continued stalled maneuvering. Engine room, starboard engine, ahead full, port engine, stop. What changed? The starboard propeller began rotating at maximum speed, driving the bow forward. The ship began to gain forward motion, but its entire hull was still being pushed sideways by the powerful, relentless current. The bow started to move ahead, but the stern continued to drift toward the marker. What risk remains? The stern might still strike the marker or run aground before the bow gained enough momentum for the rudder to take effect. The timing was everything. The ship's bow responded sluggishly to the starboard engine's thrust. The second mate reported the situation. "Bow is making way, sir. Rudder is 10 degrees hard over, but the current is holding us." The chief mate pointed toward the water near the stern. The water color was changing rapidly, indicating shallowing depth. "The stern is very close, Captain. We are running shallow." What happened? The vessel's stern was now in dangerously shallow water, and the ship's momentum was still not sufficient to fully overcome the lateral push of the current. What the crew did, Jensen ordered a critical maneuver. The moment the ship gained even slight forward steerage, he needed to throw the stern away from the shallow. Port engine, astern half. Hold starboard engine, ahead full. This was a finely balanced, delicate application of asymmetrical thrust. They needed the opposing engine forces to pivot the ship in place while maintaining a gradual forward movement. What changed? The dual command caused the ship to strain. The forward drive on the starboard side pulled the bow, while the reverse drive on the port side pushed the stern violently to starboard. The two forces, now balanced, began to rotate the entire vessel around a central point, attempting to realign it with the deep channel. What risk remains? If the rudder or the engine power failed under this extreme stress, or if the calculation of opposing power was wrong, the vessel would either become completely uncontrollable or risk mechanical breakdown. On the bridge, the lights flickered momentarily as the engines drew maximum power. The strain was evident. Able Seaman Chen reported a critical reading. Depth under stern is reading minimum safe clearance. We are scraping mud. The vessel had briefly touched the bottom. This was the worst moment. The ship was partially grounded while still being pushed sideways by the current, risking a serious breach or becoming permanently stuck. What happened? The Pacific Swan briefly grounded in the soft mud, momentarily stalling the pivot maneuver. What the crew did, Jensen held the command steady. He trusted the power ratio he had ordered. Maintain current engine settings. Do not change anything. Full power on the starboard, half astern on the port. He relied on the forward momentum of the starboard engine to pull the ship off the soft mud, and the astern thrust of the port engine to force the stern sideways and back into the channel. What changed? The tremendous power of the starboard engine eventually began to pull the ship's hull free of the soft bottom. The ship vibrated, and then, with a slow grinding release, the depth alarm returned to a safe reading. The combination of opposing forces had worked, pushing the stern clear of the immediate danger. What risk remains? The vessel was clear of the bottom, but the asymmetric thrust was still driving the ship hard toward the channel's opposite unlit side. They had solved the immediate grounding risk, but the subsequent maneuvering risk was still extremely high. The ship had pivoted hard and was now moving fast across the channel. The crew needed to immediately neutralize the thrust and regain full control. With the ship momentarily free of the mud and the dangerous green marker, the priority shifted to stopping the aggressive swing and reestablishing safe navigation within the channel center. What happened? The successful asymmetrical thrust had over-rotated the ship, and it was now moving sideways and slightly forward toward the opposite unlit side of the channel boundary. What the crew did, Captain Jensen gave the next series of precise, rapid orders to neutralize the pivot. Starboard engine ahead half. Port engine stop. What changed? The violent rotation immediately began to slow down. By reducing the starboard engine, the forward pull was moderated, and by stopping the reverse thrust of the port engine, the powerful push on the stern ceased. The ship's inherent stability and the rudder angle of 10 degrees finally started to exert a normal directional force. What risk remains? The residual lateral drift was still present, pushing the ship toward the new danger zone. The red markers on the port side. The current was still flowing strongly, and the vessel's massive inertia required careful handling to avoid overcorrection. Jensen waited 5 seconds, observing the rate of swing decrease on the compass and the speed indicator. The ship was still too far to the starboard side of the channel, but the lateral speed had dropped from 3 knots to less than half a knot. What happened? The neutralizing commands reduced the rotation, but the ship was still too far right and lacked effective forward speed to clear the danger zone quickly. What the crew did, Jensen ordered a final, measured push. Port engine ahead slow, starboard engine ahead half. This put both engines into a forward thrust, giving the ship controlled forward speed, but with the starboard engine slightly stronger, to maintain a gentle, corrective turn to port. What changed? The Pacific Swan responded. The bow began to point directly up the center line of the channel. The rudder angle was decreased slowly as the turn took hold. The speed increased steadily to 5 knots, giving the vessel enough water flow over the rudder for proper steerage. The lateral drift was finally overcome by the forward momentum. What risk remains? None immediately, but they were now moving into the final approach under conditions of extreme caution. The ship was stable, but the engine crew was running high-stress machinery. Able Seaman Chen reported the vessel's position. We are correcting to the center line. Distance to channel boundary is increasing. Ship is stable, Captain. Jensen spoke to the second mate. Maintain current engine setting. Report any change in current strength immediately. The vessel continued its approach, now under control. The heavy breathing of the bridge crew, silent during the crisis, was the only remaining sign of the emergency. The ship passed the remaining channel markers cleanly. The forward speed ensured that the powerful cross current was no longer able to push the hull sideways. The problem had been fully addressed through calculated, measured application of maximum, then moderated asymmetrical thrust. The captain then called the engine room. Chief Davies, report on engine condition. Chief Engineer Davies replied, his voice calm. Port and starboard engines are stable, Captain. Oil pressure's good. Temperatures slightly elevated from the rapid reversal, but within limits. No immediate issues. Very good, Chief. Thank you. Stand by for docking maneuvers. The immediate danger of grounding was over. The Pacific Swan had been brought back to the center of the deep water channel, maintaining its course and speed. The maneuver had been successful, relying on the crew's precise execution of extreme opposing engine forces to pivot the massive ship away from the shallow bottom. Once the vessel was safely inside the harbor basin and the pilot had boarded, Captain Jensen took a moment to review the incident. He dictated the entry for the ship's logbook clearly and factually. 16:45 hours, vessel experienced unexpected severe cross-current during approach to main channel. Lateral drift occurred rapidly, requiring emergency asymmetric propulsion to avoid grounding near green marker 5. Port engine astern full, starboard engine ahead full. Then adjusted to starboard ahead full, port astern half. Ship momentarily scraped soft bottom. Maneuver successful. Control regained 16:55 hours. Engines reported stable. No apparent damage to hull or propulsion systems. Proceeding with docking as scheduled. The second mate recorded the final navigation data points and engine settings used during the 10-minute crisis. The chief mate visually inspected the hull's draft markings after they reached the pier. No damage was visible above the waterline and the trim remained normal. The incident confirmed that in situations where the rudder is ineffective against overwhelming current, the immediate controlled use of asymmetric engine thrust is the most powerful tool. The rapid communication and precise execution of the volatile engine commands by the bridge and engine room crew had been essential. The ship was now ready for cargo operations. The experience was logged, becoming another piece of knowledge for the crew. The Pacific Swan was safe alongside the pier, resting after the sudden challenge of the unpredictable current.